we can get started. So I can kick us off, even though you two are really the star of the show. So hi, everyone. Welcome to our fireside chat with Dmitry Kan and Daniel Tunkelang. This fireside chat is on search and all the interesting topics that Dmitry and Daniel will talk about. And it's a series that's hosted by Co-Rise. Co-Rise, I'll just do my plug here. We're a new education platform that transforms the way professionals build technical, high demand skills through top industry leaders such as Daniel and collective peer learning such as Dmitry. The format of our courses are pretty innovative because we mix live instructor sessions with real world projects and fireside chats like these with operators that are experts in their field. And actually, I see a couple of students from both the search class and from other classes that are in the audience. So welcome back to you guys and welcome to everyone else here. So with that, I'll pass it on to Dmitry.
Awesome. Thanks, Judy. And hello, everyone. As I usually say, hey there, Vector Podcast is here. And today I have like a luminary guest, a mogul in search world, Daniel Tunkelang. I'm beyond excited to be talking to him and discussing the favorite his and mine topics in query understanding and content understanding. And traditionally, I will introduce myself for the first time on the podcast. And well, what I want to say is I have PhD in natural language processing. I worked on machine translation back in the days. I'm currently in two roles, principal AI scientist with Silo AI. It's a consulting gig. And recently I entered the job as a senior product manager at the company called TomTom, which produces maps and map search and navigation. I have 16 years of experience in developing search engines for startups and multinational technology giants. Most recently, I worked on multilingual web scale search. I also claim to be an expert in vector search engines, and I'm the host of Vector Podcast, which focuses on this stack, but also beyond that on search at large. I'm also blogging on Medium. And as I said, I'm beyond excited to be talking to Daniel today. And as a tradition, Daniel, could you please introduce yourself to me and our audience?
Sure, Dmitry. Thank you for that. I'm Daniel Tunkelang, and I've been working in search for, I guess, a little bit over 2 decades. I started after completing my PhD, not in anything to do with search or information retrieval, but actually in network visualization. I shortly ended up teaming up with a few folks to start a company called Endeca back in 1999 that ended up focusing on e-commerce search and to some degree, enterprise search in general, site search. I was there for 10 years as the chief scientist. And then I went to Google, where in fact I worked on search in local search, part of the Maps search team as a tech lead. I moved ironically from the East Coast, I'd been living in New York, to Mountain View to leave Google and join LinkedIn, where I first ran the product data science team, but ended up coming back to my first love of search. And it was at LinkedIn where I started a query understanding team and shifted my focus, which had really been more around faceted search and interaction, to query understanding. After leaving LinkedIn, I decided to go off on my own. And for the past 6 or 7 years, I've been what I like to call a high-class consultant, trying to bring search to everybody who needs it, which turns out to be a lot of people. And then last year, I discovered the wonderful folks at Co-Rise and started teaching these classes with my friend and colleague, Grant Ingersoll.
Fantastic. And I can attest to the course having been a student at your course. Fantastic course. I've learned a lot. And yeah, I'm a happy owner of this certificate as well. So I can prove to future job employers that I have passed it. And actually, I watched one presentation you gave at the CIO Summit 10 years ago. And one key phrase that I took away from it, or suggestion, you said, science is the difference between instinct and strategy. And I wanted to a little bit like ask you to talk to the role of science in everyday search engine development and research. Do you continue to view it that way 10 years forward?
I do. It's funny because anybody who watches that is probably the only recording of me wearing a suit on any sort of video. This is a science strategy talk. And when I was thinking at the time, as a data scientist, a big part of my job was getting people to use the scientific method in their work, whether that was A/B testing or having clear falsifiable hypotheses and so forth. Now, don't get me wrong, instincts matter a lot. For example, if you go to a search engine and you're not happy with what you're seeing, your instincts are probably right. There is probably something wrong. But if you say, I'm not seeing the results I like, I'm going to add a synonym entry, I'm going to turn up one of these knobs to see what I get, then don't get me wrong, you'll sometimes get improvements. Instincts are not useless, but you won't have a way of being certain that you're getting improvements. And you may sometimes get improvements that happen to work in that particular moment at that particular time, but which you can't explain or sustain. And so science is about using techniques like what other people might call randomized controlled trials, what we like to call A/B tests. The science imposes a certain amount of discipline, and it keeps you honest, which I do think is the difference between running on instincts that may or may not work and being able to pursue a strategy where you not only can see whether or how things work, you can measure this as well and repeat what you do. So I still hold to that with or without the suits.
Yeah, this is fantastic, and I highly recommend also to watch that video, even though it was for high, top executives. There is a lot of logical elements to it that you can apply in the day-to-day work. And I remember also one quote from the book called "How Google Works," that if we argue and we have data, let's look at data. But if we go by opinions, let's go with mine. And it was written by vice president of that area. So basically he's a hippo or sort of top that ladder. So why not actually follow the hierarchy there? But yeah, I agree that if you have data, look at it. If you don't, try to collect it, right? Yep.
Yeah, I mean, indeed, I mean, data is the equalizer, but it's for those of us who are not CEOs, it's how we get things done.
Yeah, absolutely. By the way, I wanted to also say a couple of words on logistics. Please send your questions on the chat, and we will handle them in the end of this session. Yeah, and 10 years forward, I've read your message on LinkedIn where you said a little bit on sad tone. Not everyone shares my passion for search. But I suspect that many would be more excited about search if they understood it better. Was it just a moment of despair, or was it a moment that you thought, okay, I need to approach it differently? I can keep blogging about query understanding and content understanding, but how can I actually open the doors to the minds of new people, potentially students in this field? What was going through your mind when you wrote that?
So I'm an optimist. So I'm if 2 years of a pandemic and all the global crisis can get me down, I'm certainly not going to despair just because not enough people are excited about search. But I have seen that our technology industry tends to have certain kinds of fads, and say, in fact, back in the 90s, everybody was excited about search. For those of you old enough to remember, Google was not the first major search engine. There were people using Alta Vista, there were people using Yahoo, and so forth. And then after Google took on the scene, many people said, oh, search is done. Now, I happen to not be one of those people because I was at a startup, which actually also started in 1999 working on search. And I said, no, search isn't done at all. I mean, we were trying to help e-commerce companies, and we saw that there's a lot to do on search. Now, you might think that 20 years later, search would finally be done. But interestingly, there are still so many opportunities, in fact, using some of the latest developments in machine learning to do so. But what I've seen is that people don't necessarily gravitate to search as an exciting problem. They're excited about voice recognition, about what they perceive as AI in general, which they may see as question answer, which at the heart of it has a lot to do with search as well. But they don't realize that, that humble little search box in which they're typing and everything going on between it is still an extremely exciting area of development. And I think it's because it does look so simple that they don't imagine what can you do? Change the size of the search box, change the font, what's actually going on behind that. So my hope is that when people see the complexity involved and the way in which search is amenable to the very techniques that they are excited about, they'll then say, oh, wow, this is great. And then on top of everything else, it's a place where I can have a huge amount of impact, a measurable impact on the way that people interact with machines. So no despair, just maybe sometimes a little bit of sadness that people don't share my excitement enough.
Yeah, absolutely. I mean, search is a fantastic field. If you're not there, consider entering or at least studying and evaluating. But it's very deep. I remember actually myself, like 20 years ago, still in the university, I was asking a friend of mine, how do the search engine works? And he was majoring in information retrieval back then. I knew nothing about the field. And he said, well, we use inverted index. That's how we represent the documents. But then I was still not satisfied. I asked him, hey, how can actually search engine know what I want to find when I don't know myself? Like if I start typing something in the keyword box, it's like a chicken egg problem. It means that I know something already of the subject, right? But what if I know nothing about it? And so in my mind, I started hypothesizing that maybe we can build a search engine which will kind of refine the query. I didn't know how to do it, but I was just, thinking in my mind that it's possible. And now, so many years fast forward, we apply machine learning to search. And what I wanted to ask you, why do you think we need machine learning in search today? Like there are other ways to satisfy the user intent and sort of calculate it, understand it. Then there are other things like established techniques with manual boosting and manual features that you can curate. And many companies, I think, still do it. But what's your take on machine learning role in search today?
So certainly when I was working on search back in 1999, I didn't even know much machine learning. I'd taken a class that was highly theoretical, but I managed to help build search. So clearly it's possible to do it without machine learning. And as you said, many people still are working with completely hand-tuned systems. I think that machine learning plays a few roles, though, in, I think what you could say is modernizing search, but making it do things you really couldn't do before. So for one thing, when you're doing all of these hand-tuned boosts, right, which are typically saying, oh, I'm going to have a bunch of factors that affect me. I'll change the weights on those. I'll see what can improve. Effectively, you're performing an optimization problem, but you're doing it by hand, where you're saying, let me go a little bit in this direction, a little bit in that direction, let me see what it can do. Well, the main technique that machine learning does is optimization, only that it does so by formalizing the objective that you're optimizing for, and then using mathematical techniques like variations of gradient descent to look for the place that is optimal. Well, it would be silly for you to do things by hand that there is an existing architecture to do that. But the other thing is that when you do things by hand, you're very unlikely to be able to move too many knobs by hand. 3 or 4 factors you can handle, 100 factors, almost certainly not. And that tends to be the big win of machine learning, is that because of the way that it automates what you would otherwise do by hand, it allows you to do things at a much larger scale and yet sort of keep your wits about you. Now, that's usually what people do when they're concerned about ranking. But the other real breakthrough in machine learning today is that in areas like query and content understanding, machine learning often allows you to solve problems you'd have been very unlikely to solve by hand, to recognize when a query comes in that it's in a particular category or that particular entities, people, brands, and so forth are mentioned in that query, or to figure out what a piece of content is about and get a representation that you can then use to inform what should be returned. And that's an area where it's not new that you can use machine learning there, but the ability of systems to do so using the more modern AI techniques of word embeddings and the like have dramatically changed the quality of that. And it's a breakthrough that I can only think of comparing to, speech recognition has been around for a while. But if you use speech recognition systems in the 1980s or 1990s, you thought, oh, they're very cute, but they'll never be useful. And today, we take for granted that they work well enough that people who had no other option could actually manage with them. And I would say that machine learning in search has now reached a point where it would be silly not to use it if you have the possibility, if you have the data to do so.
Yeah, absolutely. Especially if you sit on a pile of data, right? As they used to say in the age of big data. But of course, there are still niche areas where let's say you launch a startup. So you don't have clicks. Maybe you can measure clicks some way, but let's say you don't have clicks. You don't have any user feedback yet. I think at that point, you could still apply machine learning, right? Like deep learning. Hopefully we'll get there. But before that, I think when people talk about ML in search context, they quite often mean, machine learning based relevancy, learning to rank, like you learn a function which will rank your documents. But in a way, what can ranker find by itself? Not much. If the data is not there, if it's not categorized. So what's your view on where machine learning can bring a lot of benefit upstream? And I think you touched on it, like query understanding and content understanding. Can you drill a little bit more into that, especially from the point of view how you approach this task, where you start?
Sure. Well, as you know, and anybody listening has read what I have to say. I like ranking. Some of my best friends do ranking, and even I do it occasionally. But I think that ranking has been overemphasized in search in general and in machine learning powered search in particular. So if we think of what ranking does, it says we have a search query, we have a potential result, and we score it with a function that will then determine the order in which we present it, assuming that that result is a candidate to be considered. And if you go back to the original models of information retrieval, they act as if every document in your corpus could be scored. The only reason you don't do that is you can't afford to, it's too expensive. But that's the gist of it, a scoring function on the query and document, and in some cases, even on the user. Now, that's a lot of input into a function. It's quite a different way that you might approach the problem is to say, I have a query. I'm going to try to represent that query as usefully as possible without looking at any documents first. Also, before I even see any queries, I have documents. I'm going to try to represent them as well as possible before I see any queries, or at the very least, before I see the particular query that someone's going to make. I might use the history of queries to inform my approach. So now we've factored out this original scoring problem that said, throw everything at a scoring function, and said, no. We're first going to say, let's understand the query in a representation that distills it to its essence. We have already understood the content, the documents, in a way that distills them to their essence. And now, when we even decide what to retrieve, we're going to use those representations that already have done some of the work for us. In the case of the documents, we did it offline. In the case of the query, we have to wait till we see it, unless it's maybe a head query we've seen before, but we do it once for the query, not once for every result. And we can use that to then say, well, roughly speaking, if we have represented the query and the content in a similar space, retrieval, that is deciding what documents we should look at, is much more of a matching problem. In fact, if the space uses a similar schema, for example, if the query is mapped to a category or a set of categories, and the documents have been categorized using the same set, we can say, well, we should probably retrieve documents from those categories. Or if we may have other structured data we can use that way. And what ends up happening is that a lot of the work that ranking was doing, which was essentially trying to say, should I retrieve this document at all? Is this document relevant enough to the query that it should be in consideration? This query dependent aspect of ranking can be solved as saying, basically, once I have the query and the content represented in the same space, do they, is that overlap there? So what we're basically changing the first order bits, the high order bits of ranking into more of a classification problem, which we're in turn saying is really, look, once we have the query and the content in the same space, figuring out if, what is the content that matches the general gist of the query should be an easier problem. And then ranking is more, oh, well, a lot of things match, but some are better than others. And that's of course, where's machine learning fit? Well, machine learning is how we get those representations. It's how we turn the query into a more useful representation, how we turn the content into a more useful representation. But it is by treating those things as something of an isolation, it allows us to be a lot more directed than we are with ranking, and in my experience leads to far better results.
Yeah, I remember at the course Search with ML taught by you and Grant Ingersoll, you gave that brilliant example that stuck with me. I believe it was Best Buy implementing, correct me if I'm wrong, implementing the query understanding functionality where if you typed iPhone or some product that they didn't have at the moment, they would actually use query understanding to tell you that they don't have a product. They would not even go and search it. And I mean,
I think the example was this B&H photo with iPhones, but an example that's even more fun is with Netflix, where I don't have much insight as to the internals there. They haven't been one of my clients, but Netflix has a respectable but limited catalog. They don't, for example, get movies from folks like Disney that is quite protective of its catalog. But Netflix knows when you're looking for a Disney children's movie. And when you do that, rather than trying to simply match the text of your query, they show some of their children's movies. So it's an example where you clearly split out the work of understanding the searcher's intent and query understanding from simply retrieving and scoring results, because that improved representation, they know you're looking for a children's movie and they have children's movie, is far more powerful than the traditional ways in which you might score and rank results.
Yeah. I'm personally fascinated by the field of query understanding, having implemented it with my team in web scale. We've worked on job search engine as a vertical search engine, powered by the web scale search engine. First of all, it was multilingual. Second is that you had to figure out these semantic subtleties when users type opening hours or working hours, whatever the way they phrase it in their language. And that's not a query you want to execute in the job search. But if they said jobs in IT in London, that's okay. And you can use that and pass it through the filter. So query understanding kind of worked as a filter in a way. But then it also, or a classifier, you could say, right? But then it would also give us this rich semantics that we could apply in fields. Let's say if it's London as a city, you don't want to search that word just in the description. You can apply it in the field of the city on the document. And I mean, this was back then we applied rule-based approach. And and it worked fine, but it was very maybe conservative in a way, right? Especially for languages like Turkish, where they have the word ish, which is a overloaded, semantically overloaded word, and used in different contexts. It may mean a bank card, it may mean a job search, and a number of other meanings. But would you advocate for using machine learning in query understanding? I know, by the way, you wrote a brilliant series of blog posts on Medium, drilling into so many subtopics of query understanding, and especially like that you can actually utilize it in autocomplete. I was actually fascinated that you connected those two, and I highly recommend everyone to take a look at that. So what's your take on sort of rule-based versus machine learning? Would you start with rule-based and then as you learn, go to machine learning, or would you start head on with machine learning?
So I certainly see a lot of value of machine learning in query understanding for some of the reasons I was saying before. But with that said, I think that there's often a sort of a Pareto principle, an 80-20 in search problems. And when I go to people, especially folks in small organizations, I tell them, look, let's say, for example, you're trying to figure out, we'll use your job search example. Since I spent a few years at LinkedIn, it's very close to my heart. And you want to know, well, is somebody, for example, looking for a job title, or are they looking for, in say LinkedIn's case, someone's name? Or in the case of, let's say, language, maybe you're not sure what language they're searching in, you're trying to do language identification. You could start by looking at the most common queries that you see, and then just having people, your own employees, a hired crowd, what have you, to say, look, can you just label these? Now, you're not going to label more than hundreds or maybe thousands of these queries that way. At the hundreds of thousands, it starts getting a bit silly. But you can do that, and you can say, okay, maybe I've now handled 20, 30% of my traffic that way. It's not uncommon that in 10,000 queries, you easily get to that. And you can see, great, now that I've done that, now that I know, that this person's looking for a job title, that the language is Turkish, or what have you, what would I do with that? And I might say, well, I'm going to have a particular search experience in mind. If I know that it's going to be in jobs, I won't look in people, or I won't look in my content posts. If I know what language it is, I'm going to grab from that repository and so forth. And you can learn what you would do there. Now, this won't scale into the tail of your distribution, but you can learn what happens with that sort of experience. And that's actually really important, because sometimes you don't know what people will react to until you show it. And there's a bit of a chicken and egg in these things as to what is the quality of your data, but also what is the experience. But once you've decided, okay, I am going to pursue this sort of experience, frankly, without machine learning, you're never going to scale it. You're not going to label everything. And a rule-based approach to try to figure out what language something is in, or what category something is in, simply isn't going to scale. In the case, for example, of language, you would, it's not like you're going to just build dictionaries, because you'll have cognates between the languages. Or in the case of job titles, I mean, by the time you get to, chief vector search ninja, you're going to be in a bit of trouble as to recognizing that as someone's title. So that's the point at which collecting training data becomes critical. One of the nice things is, if you've done some of the work by hand, that can actually be how you bootstrap training data for these approaches, especially if you aren't in a position to do so using feedback from your own search application.
Yeah, absolutely. A quick shout out to our audience. I think it's, if I'm reading it right, just a second, Andre has a poll of how many people in this call are using hand-tuned boosts versus machine learning. I'm really, interested to hear or read this opinion. Maybe you can say about it. Yeah, and on the other hand, you've been advocating a lot on drilling into your content, and of course, some companies do this one way or another. But can you illuminate us on what you can do also on the content understanding side?
Sure. So if you think about it, if all you did was query understanding, you might be able to figure out exactly what the searcher wants, but actually not be able to find it. So content understanding is really what you're doing in order to represent content in your index in the best way to make it retrievable, scoreable. So certainly it's a great place to do things like categorization. This is especially true, say, if you have a marketplace or if you have a lot of unstructured content where you don't necessarily know what the content is about. It's also a good place to extract entities, terminology, even determine potentially the terminology best used for representing it. I mean, imagine it, for example, you have a collection of research papers. You can discover the useful words or phrases that tend to carry meaning. You can relate them to one another by putting them in a vector space where the distance between the vectors tells you how similar they are. You can cluster those. So in general, doing things that involve either classification or essentially annotation, recognizing entities or terms in those, allows you to enrich the way you index the content. You can also figure out when documents are similar to one another, because when you have these vector representations, you can take the entire document or part of the document and do that. And that can be useful for saying, oh, if you're interested in this document, you might be interested in these other ones, or maybe you're interested in these other ones, but they're more recent. And that allows you to combine what content is about with other factors like its recency, its popularity, other people that look at it. And you see this often, not just for search, but specifically for being an engine for recommendations that are triggered from discovering something through an initial search. So all of these things basically make the content more retrievable, but also more explorable.
Oh, yeah, absolutely. I can also add to that. In some settings, specifically in financial search, I happen to work at the company called AlphaSense. You may end up in a situation when you cannot actually use the hints from the users, right? So for instance, like if you do an auto-suggest and you extract themes from queries, you could actually do that. I believe Google does that to some extent. But in financial setting, you cannot do this because, banks will prohibit, using their searches with their rivals, right? You don't want to do that ever. And so at that point, you do go deeper into content understanding and you start extracting, stable themes, and maybe over time, you can also extract trends as they show up. And that might be one way to kind of combat the issue of not being able to use queries to influence your model. But yeah, you might have another setting. I'm curious to hear in the audience as well what kind of setting you guys have. My next question would be on what are available data sets? Let's say if I want to practice query understanding or content understanding at home in my lab, what are the available data sets, tools, and algorithms that you can recommend that will allow us to train these models for both of these directions, query and content understanding?
So as those of you who took the class know, we've been using an e-commerce data set from Best Buy for teaching. It's a nice data set. It's a little bit old, but it has a virtue that it has a bunch of structured data, queries, and some click data as well. And that's proven useful. You can get that from Kaggle because they've made it available freely. And indeed, Kaggle, which is at this point a subsidiary of Google but maintains an independent brand, is a great place to get data sets. This one from Best Buy, I think, is probably the best all-around one for exploring particularly query understanding, and to a lesser extent content understanding. There are certainly other data sets available. You can, for example, grab dumps of data from Wikipedia that are fascinating. Wikipedia is perhaps the best overall data set in the world, but bear in mind that it's a bit sprawling and that they don't supply much in the way of queries or feedback, and you'll have to do a little bit of work with that. There's a data set called MS Marco that's been very popular with with essentially the deep learning crowd because it's an interesting place for doing question answering. So I think a lot of the question becomes, what is the problem that you want to work on? And I would say for those of you who are already working in search in some capacity, or at least have access to data, you should really consider trying to use your own data, because usually the thing that is hardest to get in public data sets is user behavior. For perfectly understandable reasons, companies are not eager to share what their users have done, either because of the privacy concerns for their user or the competitive nature of that data. So even if you're able to find catalog data, which you could, if it's structured, use to learn content understanding techniques, for query understanding, the most powerful thing you're going to use is a collection of queries and labels for what those queries mean. But if you get a collection of data without even having what the queries are, let alone the labels, it's a little bit more difficult.
Yeah, absolutely. And can you also share a bit on the tooling side, or maybe algorithms?
Sure. So the for different problems, obviously call for different tools. On the ranking side, one of the most popular approaches that's still in use today is XGBoost, which you can get online easily enough, and it's also been integrated with, I think at this point, most of the major is certainly Lucene based, sort of Solar, Elastic, and so forth. If you're interested in classifying text or doing unsupervised learning on text, these days, frankly, I would go directly to embedding-based models, and you can use tools like BERT, or maybe a bit old school, I'm a fan of fast text, that you can get online, and you can download those, you can install them on your laptop, you can even get pre-trained models for hundreds of languages that do so. And from that, it should be easy enough. You can walk through the tutorials where you take just a bunch of labeled text examples. In the case of fast text, it's an example of Stack Exchange cooking questions associated with their labels. And in half an hour, you find that you're actually doing content classification from this. And in the course, we do this sort of thing with the Best Buy data as well. But it's amazingly easy to see that these sort of tools will start to give you reasonable looking answers. Now, getting from reasonable answers to answers that you're happy with and can incorporate into a search experience can be the difference between an hour and a week or a month. But my hope is that by seeing how easy it is to get started with these, you get tempted enough that you say, great, but 80% isn't good enough. I need to get myself to something I'd be willing to put in front of my customers. And to be fair, there's a little more hard work to make that happen.
Yeah, absolutely. Vector search, by the way, is my favorite topic. I talk a lot about it and blog as well. And I'm super happy that you mentioned this now. And the gateway here to this topic is the connection with content understanding is one of the techniques called doc to query. Essentially computes possible queries and then augments your document. So you don't actually need to step in the unknown field of vector search, trying to re-engineer your search engine. You can actually keep your search engine architecture as it is, and you just basically augment your documents in the hope of increasing coverage and actually precision at the same time of future queries. So what's your take on these techniques, emerging techniques, but also what's your take on the role of vector search in general in the search engine design today?
Sure. So if you think about it, the doc to query approach is similar in spirit to saying, well, I'll have a known set of fields that I would assign to the document in a traditional inverted index or posting list. And indeed, I mean, the limitation of the older approaches is that they kind of force you to a limited vocabulary. And now the query vocabulary is literally the language of users. So I think that's a great way to do things, and to handle also that documents have often a lot more variability than queries. It's typically only so much people are going to do in a search box, but documents can be in all shapes and sizes. So I'm certainly a fan of doing document enrichment that's query friendly. Or conversely, if you're going to do things on the query side, to think of a query essentially as a bag of documents. I think even though there have been these explicit, what they call, two-tower approaches that try to sort of meet halfway, I think it's perfectly fine to say, well, we'll think of one of these things as more fundamental and map the second one to it. As for vector search in general, I think, first off, I think it's great. I mean, the idea that you can think of meaning as this point in a high-dimensional space and explore things around it, even though in a way it's not a new idea, right? People have been using vectors at least as far back as techniques like TF-IDF, where the bag of words representation of content was simply a vector in the space where every word was a dimension. I'm glad we've gotten a little bit smarter about that over the past few decades, and certainly what we can do now with embeddings is amazing. With that said, I think that sometimes people use vectors as too much of a sledgehammer. For example, if I do a query on a site for cat, turning cat into a vector, and then turning all the documents into vectors, and then sorting them by cosine probably is overkill when how much information am I going to get out of a single token cat? Now, figuring out whether something is a cat, as Google showed, may require a huge amount of machine learning, for example, if it's based on taking images. But it's probably safe to say that, at least at the query level, there's only so much nuance you're going to get out of a one-word query corresponding to an entity. And if a traditional approach where a pure vector-based approach would say, well, I'm going to take the vector for my query cat, I'm going to take all of the vectors for my documents, which have varying degrees of catness implied, I suppose, in those vectors, and sort by their distance. It probably makes sense to start by saying, maybe I could have actually, either using a doctor query or more traditional methods, annotated the documents in such a way that for the first pass, I could get, the things here. And in case of queries that simply, has only a token in it, there may not be much I can even do at that point in terms of the use of vectors. Now, as the queries get longer, have more signal in them, this game changes completely, right? If I'm saying I'm looking for, a cat wearing a red bow tie, well, with a query like that, it's very unlikely that a traditional approach is going to be able to say, well, what do I do? I'm going to look for those words, some of them, some other ones, is a necktie the same as a bow tie? Would a cat in a tuxedo be better than just your typical cat pictures and so forth? At that point, the game has changed, because it's not a simple binary question anymore. And those gradations of similarity make a huge difference. And there, I think you lean much more heavily into things. Now, I'd say that it's still the case that doing a pure, grab everything as a sort of a nearest neighbor search in a vector space can be computationally challenging, and it can lead to sort of unpredictable results. So most people today are still doing their first pass, at least, by using traditional methods. But I do know folks who are increasingly trying to use vectors from the get-go, but just by using sort of coarser-grained vectors or various techniques to make that first pass be quick enough. So I think we're going in that direction. I think that there's still a lot of value, both for computational efficiency and for kind of explainability, in using traditional inverted indexing techniques where you can, especially for the early stages of retrieval, but for either for getting these nuances or for, say, increasing your recall by retrieving things that you might have lost otherwise. we're seeing increasingly the use of vector search to get them. And, we're doing this talk now in 2022. I suspect in a few years, the inverted index methods will become more and more confined to those cases where the data is really just simple binary. And I think that will always exist. I think this kind of there'll always be the sort of head cases of it, but the use of vectors is only going to expand.
Yeah, absolutely. Or like especially where I would say inverted index will still be needed if you are looking for an exact phrase. Like you don't want to say, hey, vectorize this and find this similar. No, I don't want similar. I want that exact thing. And of course, there are other things that need to be improved in vector search, like, I don't know, BERT model, according to one study, it doesn't recognize negations, and it might be actually crucial for some search scenarios or sentiment analysis. And also another thing is that by now, at this point, sparse search BM25 based methods is a very strong baseline when you compare these methods across data sets, across tasks, and so across domains. So I think the future is very bright in this direction, and I think a lot of folks are trying to combine this method. So I'm happy that you are looking at this as well, and I believe you'll be teaching about this as well. We are quite close to the top of the hour, and I'm happy to see so many queries coming in, but I'm going to ask you my favorite question, the question of why. It's this kind of mystical, philosophical question. You are the most celebrated search engine professional today, one of the most, if not the most. You've done everything there is to do in search, in my opinion. Like when I look at your CV, even you consulted Zoom, through which we're doing this session. So that speaks volumes. And I just wanted to ask you, what drives you to continue focusing on search engines and especially teaching about it?
So search, if all of the problems that, of all the things we do with technology, I believe is the one that puts us as human beings front and center, right? So much of what you see, and specifically machine learning and AI, is being done to us. Feeds, recommendations, advertisements. But search starts with people expressing what they want. And, in my version of the future, I'm not a dystopian, but I believe that machines will help us, but that has to start with us expressing our intent. So that to me is why search is so exciting. And as for why to teach it, well, it comes back to what you asked in the beginning. I'm despairing that there's enough excitement about search. I'm not despairing, but I do think that the need for people to be building great search is not met by the supply of people who have learned about it. And as much as I enjoy personally working as a consultant for companies, that's not exactly a scalable approach. So what I see is there's so many people out there who know enough that with a little bit of a push, some combination of the basics of domain knowledge that we're teaching in our fundamentals class, but also the kinds of techniques, and to be fair, a somewhat opinionated way of showing those techniques in the Search with Machine Learning class that focuses on query understanding, on content understanding, that takes dense retrieval, vector retrieval, and puts it in context, is just the nudge they need to get over this. You don't need to spend years and, not everybody's going to get to do a PhD in information retrieval and machine translation. But I think that today, if you are a software engineer, if you have a basic knowledge of coding, and you learn a few of these things, you can do wonders with the tooling that's out there. And then from experience, you'll develop the rest of the sorts of skills that you need. So I'm excited that I can be a part of enabling the next generation to just run circles around anything I ever got to do. And I look back at the work we did in the early 2000s, and it looks so naive, although I think we were working at least on the right problems, but without the machinery we have today. And I just think, in another 20 years, I look forward to looking back on the naivety of what we thought search was, back at this point.
Yeah, I'm equally excited. This is very deep, Daniel. Thanks so much. And please keep doing what you're doing, because I really, really enjoy reading your blogs. I need to also read your book, by the way, on faceted search. And before we move to the questions from the audience, is there any announcement you would like to make to our audience?
Well, for those who don't know, we're going to be teaching these two classes in June. There's a Search Fundamentals class, which is a 2-week class intended for people with no background in search, and this Search with Machine Learning class that will start 2 weeks later, so people can take both, that focuses on search with machine learning. So we're going to talk about query understanding, content understanding, and vector retrieval. That will start, the first course will start on June 6th, the second on June 20th, and these classes are available to anyone in the world. We make sure, Grant and I, that we cover the time zones well and are available asynchronously. So I hope that, I know that some of you have already signed up, some of you have taken the class before, but what we experienced when we taught this class before was an incredible community, which Dmitry is indeed a part of, and we're excited to keep going with this.
Absolutely. And I highly recommend you to take this course, or both of these or one of these. And firsthand experience, it was breathless run. And I was like, yeah, it's every single week I need to hand in a project. And it's not just theory. And theory, by the way, is very deep. If you have time, go and read all the write-ups that Daniel and Grant have done on the course, but also the actual act of coding, the actual thing that you see how it evolves in your hands. It's amazing. So awesome. Let's proceed to the questions from the audience. I will take the first question from the Q&A panel we also have in the chat. So the first question is from Himanshu. Apologies if I mispronounce your name. Hi, Daniel. Any specific book to get started with search with elements of machine learning? Thanks.
Yeah, so I mean, I'll say this. There's a lot that's been written on learning to rank. I think Chris Manning's book discusses it. Ricardo Vaz-Yates's book might. I'll admit it's a little bit older. What I think you're going to be less likely to find, though, is that stuff on, say, query and content understanding. There is a book. It's really more of a collection, a survey of essays on query understanding for search that was published, I forget if it was last year or the year before, a little bit expensive, but you can look that out there. If you're more interested in things for free, my blog at queryunderstanding.com is available, and at least we'll give you a survey of the techniques there. But to be clear, it's very focused on query understanding as such. I'm writing a series on content understanding, unimaginatively, contentunderstanding.com, that starts doing the same thing there. But from the perspective of books, I would say that probably Chris Manning's information retrieval book would be a good place to start on information retrieval in general. And the query understanding collection of essays is, frankly, the best published resource you're going to get for that.
Awesome. Hope that answers your question. I'm sure the next one I'm going to take from the chat. It's from Chris. What are your recommendations for integrating information retrieval, retrieving documents with question answering, returning answers within a context?
Yeah, so question answering is really exciting, right? And that the this idea that you could get information instead of just a document. If you think about the way we've gotten there, a lot of it starts from something called passage retrieval, or even before that, search snippets. Essentially, if you think about the way Google looked 5 to 10 years ago, you would see that sometimes as you looked at your search results page, your answer was in the few words that were highlighted for the result. But now it's more likely that you'll see that sentence extracted and put near the top. And I would say that a lot of question answering today feels a lot like passage retrieval. That is, find that sentence. Although I would say that while before that tended to be retrieving a passage that contained essentially the exact words you'd used, maybe with a little bit of variation for stemming or synonyms, nowadays it's more likely using a vector-based approach to be a sentence or passage that is similar in the vector space. That's super exciting. However, what people really want is that even though there is no sentence in the content that exactly answers your question, somehow the search engine will be able to not just be a search engine, but a kind of answer engine and say, oh, I'm able to synthesize content from different places, or understand your question and learn that. We are not there. I mean, of course, you can ask, what's e to the I pi plus 1, and it will say 0, but that's cheating, right? That's really just doing this. You can play with Wolfram Alpha, that is a more sophisticated version of trying to essentially parse what you ask into a question that it can then execute in a language. But I think doing that on general information, we are far away from. It's exciting, but that will require a generational improvement.
Absolutely. I agree on that. The next question from Q&A panel from Donnie. What roles do curated controlled vocabularies, term lists, name authorities, taxonomies, and so on play in practical approaches to query and content understanding in your experience?
So they're huge. And I'm glad that you asked this, Donnie. That basically the collecting these sorts of curated vocabularies can be a great way to label the content and have targets for doing any kind of machine learned labeling. So if, for example, what colors things come in, then those, and people tend to look for colors, then great, you can actually say, great, I'm going to look this way. Or if I know what subjects people are interested in, those would be the subjects I label content with and where I target things for queries. So in a way, having these vocabularies changes what would otherwise be an unsupervised problem of saying, well, I'm hoping I can get some representation of what this is about and what the query is about and match them, which if I don't have vocabularies, I'll be somewhat unopinionated in how I do this. Having controlled vocabularies can say, oh, those are the ways in which I will try to represent things. Even if I'm using vector-based methods to get there, they give me some alignment on the space, and having multiple such vocabularies might say, well, sometimes I might be interested in one aspect of this content and sometimes in another, right? So I might be interested in the color, I might be interested in the product type, I might be interested in the material. So I would say that having these vocabularies can make a big difference. And since you bring up thesauri, it can be helpful when there's a vocabulary gap between the way people ask things and the way things are represented, to use a thesaurus for query expansion. You have to be careful because these thesauri tend to wreak havoc with the context in which those words occur. But still, they can be great for generating candidates for retrieving more results.
Awesome. I think we still have time, even at the top of the hour, for the last question from an anonymous attendee. So, Daniel, you talked about query classification for the retrieval side of things, but that can be a slippery slope if content isn't 100% correctly categorized, and often it's not. Therefore, our recall would be negatively impacted by using query understanding as a hard filter. Any input on that?
Absolutely. I mean, I was burned by this myself when I was helping a client with trying to target promoted search results. And I said, oh, we should only put them in the right category. And indeed, because there were some categorization errors, this had such a negative impact that I stormed into the room saying, close the test, we're losing money. And I felt very embarrassed because it turned out that indeed, this is exactly the problem. The content wasn't classified well. Of course, I mean, the first thing I would say is invest on the content side, because if you're able to classify queries, you probably can also invest in classifying the content. And by the way, even if the content has been, say, categorized in a way that you're not allowed to override. right? Maybe you're a marketplace, or you're the content that, you don't own the categorization. For example, on LinkedIn, if I decide to say I'm an attorney on LinkedIn, LinkedIn's not going to just automatically change. It's like, no, you're actually not. You're a cat. But but it can still classify me and say, you kind of look like a software engineer. And you can use inferred categories in your retrieval. There's no prohibition there. I'd also say that, maybe the content isn't 100% categorized because there are some similar categories. Well, you can always take query classification, it's not a hard and fast rule, but more like guidelines, and say, well, I'll return things in that category, but I'll also return things that say were referred in that category, and maybe I'll even return things that are in similar categories. Oh, and by the way, if I'm not 100% sure on that category, even on the query side, maybe I'll take the top few categories that I thought were possible. There are a lot of ways in which you can use what you've seen, what you've learned about the query and what you've learned about the content as hints. And with all these things, it's a precision recall trade-off. And you have to generally decide what's the cost of losing that recall versus what's the cost of having the annoyance of poor precision. And it will depend.
Absolutely. It's a journey. And I've enjoyed this conversation so much. I've learned new things. I will rewatch this podcast myself. And thanks to everyone for asking your questions. And thanks, Daniel, for answering them brilliantly, as you usually do. Hopefully, we covered all the questions from the chat and from the Q&A panel. And thank you so much. And I think where you don't feel comfortable or you don't know yet, I highly recommend you to take the course or a course on search, and go from there. Experiment, be bold about what you do in your experiments, but just apply science and apply the knowledge from the moguls like Daniel and Grant. So thank you very much, Daniel, for your time and for your wisdom today.
Thank you, Dmitry. It's a pleasure. Have a great evening.
Thank you, everyone.
Thanks.